Did it just close? Oh, it's frozen. What a good way to start the video. All right, let's go here. Did you learn the exponent 0 last year?
Yes.
2 to the 0 is equal to 1. Why?
That's how it is.
It's just a definition. There's no logic to it. They just decided
There's a definition that says anything to the power of 0 equals 1.
anything to the power of 0 is equal to 1. That's just it. That doesn't make sense. It's just a rule. Well, we're going to see if we can explain why it works. A couple different ways. Okay? We're going to try and explain why it works using some of our rules. First of all, what are your rules if you had to simplify this? Minus the exponents, right? So you get 3 to the 2, which is 9. Good. Now, let's say I decide not to put 3 to the 5 on the bottom. I decide to put 3 to the 7 on the bottom. What happens when you have the same number divided by itself? You get 1. Right? 10 divided by 10 is 1. 100 divided by 100 is 1. 72 divided by 72 is 1. Now, if we used our exponent rule, what would we get?
0.
We would get 3 to the 0. So there's one way that you could say, hey, maybe it makes sense that something to the 0 should be 1 because of the quotient rule. Another really nice way to see why something to the 0 is equal to 1 is to look for patterns. 3 cubed is 27. 3 squared is 9. 3 to the 1 is 3. Now, if I wanted to find, if I go up, what pattern do you see on the left-hand side? Exponents are going up by 1, so the next one would be 3 to the 4. And if I look on this side, what's happening as a pattern? You're timesing by 3 each time. And sure enough, 3 to the 4 is 81, because you could times by 3 as well. That's going up. The question is, could I continue the pattern if I went down? If I was going down, now my exponents would be going down by 1. So if I went 1 more, I would get 3 to the 0. What pattern do we see if we're going backwards? You're dividing by 3. So if I divide by 3, I get 1. And it fits the pattern. And now we've seen it with the quotient rule why something to the 0 should be 1. And we've seen with a pattern why something to the 0 should be 1. Did you learn negative exponents last year? I'm asking you. Not really? Do you know what 3 to the negative 2 is? 1/9. Good. So some of you have seen them before. Now, if we keep going with this, this pattern doesn't have to stop. What would happen after 3 to the 0 if I went down 1 again? 3 to the negative 1. What would happen if I took 1 and divided it by 3? I get 1/3. And if I'd kept going with the pattern, I'd get 3 to the negative 2, and then I would get 1 over. If I divided by 3, I could write that as 1 over 3 squared, which is the same as 1 over 9. So very powerful how patterns work. And mathematics is based a lot upon patterns. Almost everything to the 0 is 1. And I say that because there is one number to the 0 that isn't 1. So, question is, what is 0 to the 0? Is it 0? Or should it be 1? Yeah, but we have an exponent there. Okay? Try it in your calculator. See, is it 0 or is it 1? It's error. Okay? 0 to the 0 is error. Why? Because we have a conflict. We have a conflict because 3 to the 0 is 1, 2 to the 0 is 1, 1 to the 0 is 1. What should 0 to the 0 be? 1. But 0 cubed is 0, 0 squared is 0, 0 to the 1 is 0. What should 0 to the 0 be? 0. So in mathematics, when two patterns conflict, when you have one thing saying it should be 1 and someone else saying it should be 0, and you have this argument and both patterns seem to make sense, the common thing to do in mathematics is just say, no, it doesn't work, it's undefined, it's an error. Because we can't have something equal two different things at the same time. So an important thing, couple definitions here, you need to know the word reciprocal, which you've seen before when you divide fractions, multiply by the reciprocal. Two numbers whose product is 1 are called reciprocals. And a reciprocal is just a fraction that has been flipped. I like highlighting definitions. Pretty. Reciprocal of 2 sevenths is 7 halves. Reciprocal of 3 to the negative 2 is 3 squared. Weird. Because 3 to the negative 2 is 1 over 9, and the reciprocal would be 9 over 1. And this is going to become important because thinking with negatives is harder. Thinking with positive numbers is easier because we have a definition for what 3 squared is. It's 3 times 3. So what's going to end up happening is when we have a negative exponent, we're going to think about the fact that that is the same as making a positive exponent but doing the reciprocal, put that number on the bottom. Negative exponent rule. So you get rid of the negative exponent and just rewrite the power on whatever other side of the fraction you have. So there's one example. 3 to the negative 2 would be 1 over 3 squared. One over 4 to the negative 3 would be, and you would move it up to the top, 1 times 4 to the negative 3, and then there'd be a 1 on the bottom. Oops, sorry, 4 to the 3. That's another example. You can even do examples with multiple 1s in there. Let's say I have a fraction that's 2 times 5 to the negative 7 over 3 times 4 to the negative 3. Basic idea with a negative exponent is you get rid of the negative exponent by just moving it to the other part of the fraction. If something's in the numerator, the power will get moved to the denominator. If something's in the denominator with a negative exponent, it'll get moved to the numerator. So looking through this, will my 2 get moved? does it have a negative exponent? No, it's just a 2. So it would stay there. My 5 to the negative 7 will get moved. It'll go to the bottom. The 3 on the bottom would stay as well. The 4 to the negative 3 has a negative exponent. It would move to the top. Do you remember doing questions like this last year? If you went to subtract, though, you would get a negative. So probably what your teacher just said is, where do you have more 7s? On the top or the bottom? You have more 7s on the bottom. How many more 7s will you have on the bottom? Like if I wrote it all out and canceled them out, a whole bunch would cancel except for 3 of them. So you would be left with 3 7s on the bottom. Now your negative exponent rule, or your quotient rule, would say you have to subtract. And when you subtract, you would get 6 minus 9, which would give you 7 to the minus 3. Of course, the 1 over 7 cubed means a lot more because we know what that definition means. 7 times 7 times 7 on the bottom. Seeing that negative exponent is not something that we're as used to. So without a calculator, and all of your regular exponent laws are the same with negative exponents. So first of all, our definition of a negative exponent, your first bit of work, change it to a positive exponent. You get 1 over 7 squared. It says evaluate. Evaluate means there should be no operations left. You should be able to write your final answer as a number, whole number, rational number, natural number, whatever it is. There is an operation here. 7 squared is 49. Now we've written our final answer as a rational number, as a single number, so we're done. What's the exponent rule when you have a fraction? Does that negative 3 go to just one of them? Goes to both. So there is an exponent rule from last year. It would go to both of them. If it went to both of them, we have 2 negative exponents. The 10 will go to the bottom and become a positive exponent. The 3 will go to the top and become a positive exponent. We still have operations. What is 3 times 3 times 3? 27. And what is 10 times 10 times 10? 1000. Now we've written our answer as a single number. We have evaluated. A decimal? Yeah, you can write it as 0.027 or leave it as a fraction. Generally, as you get to higher math, fractions are easier to work with than decimals. So we like to start leaving things more often as fractions than decimals. Here we have a negative exponent. It will move to the top of the fraction. Can you see that I don't have to write anything on the bottom of the fraction because there would just be a 1 there when the 5 to the negative 4 gets moved? The 1 on the top would still stay there, but it gets multiplied by 5 to the 4. So in the end, this is just 5 to the 4. What is 5 times 5 times 5 times 5? 625. Good. Now in D, we have a negative. When you have a fraction that's negative, negative 3 over 2, does it make sense that that's the same as negative 3 over 2? Or you could say 3 over negative 2, but it is not equal to negative 3 over negative 2. Where you put the negative doesn't matter. But you can't put the negative both on the top and the bottom because a negative divided by a negative is positive. So if you have a fraction that's negative, it can either be with the number on the top, the number on the bottom, and when it's out in front, it's like a -1 out in front, although we haven't written the 1. A -1 times. So I'm going to just put it on the top because then I would have a -3 to the -4, and I would also have a 2 to the -4. Because that -4 has to go to the negative as well. This is a negative exponent. The whole -3 gets moved down to the +4. And now that we've got positive exponents, can you evaluate? What is 2 times 2 times 2 times 2? Right. And 3 to the -3 to the 4, -3 times -3 times -3 times -3. Positive 81. Some people with fractions, with negative exponents, like to do the negative exponent. Do you see what happens with the negative exponent? The fraction gets flipped. So some people like to do with negative exponents, they like to just flip the fraction and change the exponent to positive. Can you see that that would give us exact same answer? A negative to the power 4 will become positive. 2 to the power 4 is 16, and 3 to the power 4 is 81. (16 to the -5/4). Ooh, this practice is what we did yesterday. That'll be 1 over 16 to the +5/4. Mental math, 16 to the 5/4. Review your notes from yesterday. 32. Again, what did we do with fractional exponents yesterday? Yesterday said if I have a fraction as an exponent like 5 over 4, I could rewrite it as 1/4 to the 5 because that's the same as 5/4. And 16 to the 1/4 is the same as the 4th root of 16. And since we know the 4th root of 16 is 2, we have 2 to the 5, which gives us 1 over 32. Try F on your own. Again, with a fraction, the negative, I showed you in D, there's sort of 2 different approaches you could take to that. Choose whichever one you like the best. Okay. How many people put the -1/2 in first? How many people chose that method? Okay, good. And then this one would go to the top, and this one would go to the bottom, and they would become positive exponents. 36 to the 1/2, from yesterday we learned that that's the same as a square root. And 25 to the 1/2, that's the same as a square root. Square root of 36 is 6, square root of 25 is 5, so we get 6 over 5.
You just went straight to 36 over.
That's the other way.
Like you
So
you just skip the whole first step.
the other way is to say, I'll flip my fraction first to the 1/2.
But I
And then you went right to this.
No.
You're just skipping writing all this stuff.
Yeah, that's what I was asking, is if I just didn't write out the first step, and I just went straight
Straight to this one?
36 and, yeah,
That would be fine,
okay.
right? The only place where skipping steps really is dangerous is if you skip a step and then you make a silly mistake while skipping the step. Then you lose all, sort of like you haven't even left a trace to show what you know.
Yeah.
So that can sometimes be dangerous. But these both end up with 6/5. One more question. Here's a formula with fractional exponents and negative exponents. It's a crazy formula. Should I make it bigger? Those numbers are getting small. Now I'm going to give you the answer so that you can check if you are able to type this into your calculator correctly. So you want to get your calculator to say 1.2412 ... Once you've got that answer, you can just work on the homework, put it at the bottom corner there. If you're having trouble with your calculator, call me over and I'll help you with it. But you can type it in. You can even type the negative exponents into your calculator.